again. So a proportional relationship is a relationship where two quantities have a ratio that's consistent. The ratio stays the same, which means when I find points along the line, each of the points break out to a ratio. A ratio is like 1/2 equals 4/8. That's a ratio, right? So all proportional relationships go through the origin. That means they have one point on the line, which is 0, 0. Somewhere on that line is a point called 0, 0. It's the origin. That defines a proportional relationship. Okay? It has points with the same ratio. So if I've got a point that x is 2 and y is 4, I would also have a point where x is 4 and y is 8. The points keep the same ratio. Does that make sense?
Yes, sir.
Okay. So we talked about some of this. We know that k is the constant of proportionality. That is one of those main features. K is the constant of proportionality. Later on, we're going to give k another name called m. And what's m? Slope. So it's constant proportionality, but we're also going to call it slope later, or m. They mean the same thing. They're the steepness of the line. Zero slope means it's the world's most boring skateboard park. It's just flat. Whereas the slope gets higher, the bigger the number, the higher the slope. So if you're on a slope that's 1/2, it's not very high at all. It's a good skateboard slope for people like me. If you're on a slope that's like 8, it means I'm going to the hospital if there's a skateboard involved. Yes, sir.
Well, I never got that good.
There's one right here. It's all right. Okay? So the formula that we need to know is y equals kx, where y is a point. We talk about y in x.
You're gonna have that paper, not this.
Sit down. Sit down. We gave it last week. You already have it in the book.
What if he wasn't here?
Y equals kx. When we talk about the points y and x, we're talking about a coordinate. Every coordinate is listed as x comma y, right? So if I say y equals kx, what that means is the point y is equal to k times the point x, where k is the constant proportionality. Now, remember, using our equations, we can move things around. If I took this right here and I divided both sides by x, I could move the x, because it's the coefficient of k, I could move it off k over here to where k would equal y over x. So if they're kind enough to give me 2 points, or give me 1 point with an x and a y, and I know that the line is proportional, then I can find k. Fancy? Okay. So one of those things, and you're going to hear this a lot too, x. X is the input. It's also called an independent variable. Independent means it picks what it wants to be. Because y equals kx, it means on the left side is the dependent variable, meaning whatever it is what k times x is. So y is the dependent. So far, so good? Now remember, what does k equal? What does k equal? Y over x. Y over x, where 1 point on the line goes through the origin. So the line itself has a point that's 0, 0. We can use y equals kx. In a little bit, we're going to kind of add to that, and I put it down here only because in the future you're going to be using these. It really is rise over run. How far does it go up over how far does it go left and right? So far, so good? Let's do a couple problems. These are our proportional relationships. I'll zoom this in a little bit. All right. So proportional relationships. 15 bicycles are produced each hour at the Speedy Bike Workshop. Show that the relationship between the number of bikes produced and the number of hours is a proportional relationship. Then write an equation for the relationship. All right. When we make a table, the top row is always X. In fact, one of those things you can do in this lower right-hand corner on each is always put in X, comma, Y. No matter what they write in their table, X, comma, Y will get it. Look for the word per, the word each. They will tell you which one is the X. So 15 bicycles are produced each hour. Well, each is one of those words we're really looking for. Each hour. So what is Y?
Each.
No.
Oh, 15.
What is Y?
Hour.
The hours.
I said hour. You said each. So I can see that.
Hours. So what is the other? What is the X variable in there? Come on.
8.
Look for the other thing they're making. What are they making?
Bicycles. Number of bikes.
Bicycles. They're making, oops, I can't spell bicycles. They're making bicycles per hour, right? Does that make sense?
Why did you capitalize?
All of his letters.
The B's not.
And
The L's not.
The Y, the C, L.
I'm almost
S.
positive the Y's not.
what's wrong?
The E is cap. Why is the E is cap?
So it doesn't matter.
I'm sorry. I'm trying to learn how to do it.
See, you would have got a point off of English for that.
So, actually, I wrote them upside down.
So bicycle is Y.
It should be Y over X. I apologize.
Yeah, I was about to say X over Y.
Thank you.
Why didn't you just put Y?
Bicycles per hour. I apologize.
Wait, why isn't the X and the Y doing?
Remember, the K equals Y over X, right? So bicycles per hour. Does that make sense?
Don't you need to switch the X and the Y?
No. X is always on top. So if I go 1 hour, how many bicycles are produced?
15.
15 bicycles. If I go 2 hours, 30 bicycles. 3 hours, 45 bicycles. And I can go on, right?
Yep.
So let's look at the equation. We know that K is Y over X, right? What's Y? Let's go just 1 point. We'll pick this point right here. What's Y? 15 over 1. So how many? What's K? 15. Now I can write the formula Y equals KX. Y equal KX is the equation I'm looking for. When they ask for an equation, they want Y equals something.
We did this a lot last year.
We've done this a lot. We'll continue to do this a lot. So I put my Y equals, now K, I already found K, right? So Y equals 15x. I can now use this equation to solve things like if we work 8 hours. So if the shop is open for 8 hours, how many bicycles will be produced? All I got to do is put it in there and say Y equals 15 times 8. So what's 15 times 8?
120.
Yeah, 120.
So In an 8-hour day, they produce 120 bicycles. And I can use that to solve anything. That's the point of an equation. Let's take a look at another one. So we've got a graph here. The graph shows the relationship between the amount of time that a backpacker hikes and the distance traveled. So what does the point 5, 6, remember it's always, and you can put right above that 5, 6, x, comma, y. X, comma, y, put it right above that. So what does that point, and let's go find 5, 6. So x is always the left and right, and y is always the up and down. So 5, 6 is this point right here. What does the point 5, 6 indicate or represent?
5, 6?
Where's dot?
No. What does it tell me? How many hours did they walk?
5 hours
And how far?
5 hours and 6.
So they went 6 miles in 5 hours. That's what the point 5, 6 means to me.
That's really slow.
Yeah.
Yeah, but they're hiking, so maybe they're like checking out birds and taking pictures,
Baby pictures?
chasing squirrels. Okay. So let's Rancy. Focus. How do I find the equation for the line? If I know that one of the points is the origin, meaning it goes for 0, 0, all I have to do is take one other point and I can find k. What does k equal? Y over x. So let's go to this point. What's the y coordinate for this point right here? This point is 5, 6. What's the y coordinate? 6. So I put 6 over, what's 5. So 6/5. Now here's the great one. You're going to love this. You do not have to simplify this fraction. You only have to reduce until you get the simplest form, but you don't have to convert it to decimals. You don't have to convert it to a 1 1/5. You just leave it as 6/5. Because what it tells us is the rise is 6. If I rise 6, 2, 4, 6, and I run 5, 2, 3, 5, I get my next point. Okay? So my equation becomes y equals, what's k? What's k? 6 over 5 x. Okay? And if you look at it, that works perfectly. 2, 4, 6, and then each of these are 2.5, 2.55. This next point is exactly that rise over run. Does that make sense? See, I rose,
Then you ran.
then I ran.
See, I'm so good.
You are. All right, let's graph an equation. Y equals 3x.
That's negative 3x.
Is it negative? Yeah. Oh, thanks. It's negative 3x. I'm reading from here. Thank you. So I'm gonna make me a table, and I'm gonna make my table x and y. Now the great thing about a proportional relationship, I already have one point. What's the first point?
-3.
No. First point.
0.
Origin.
The origin. 0, 0. I always own the origin, don't I? That first point is right there at the origin. It is, in every proportional relationship, the origin is included. So I have a free point that I didn't have to work for. Now, let's look at here. It says negative 3 times x. Well, let's make x 1. What is 1 times negative 3?
-3.
Negative 3. Okay, let's do a little better. Let's do 5. I don't want to do 5. Let's do 3. No, I don't want to do 3. Sorry, it gets too big.
No.
2. 2 times negative 3 is
-6.
negative 6. All right, I have 2 points now, right? So I go x is 1. What is y?
-3.
So I go all the way down here to -3, and I make the next point. X is 2. What is y? -6. So I got points. Then, in a moment, I'll hand you all out rulers. Then I take a ruler and I make a straight line. Now, here's the important thing. It is a line. That line goes on through the graph forever and ever in both ways. What kind of slope is that?
A downward slope.
No, look at it.
An upward slope.
It's a negative slope because it rises to the left, right? And that matches, if you look up here, I got -3, so looking at these, it's pretty good. And that'd be a good skateboard ramp. Actually, that'd be death-defying skateboard ramp at that point. Involve death and life. All right, so this is literally what we're going to do today.
What, literally?
Easy.
Like legit.
Legit.